So now we will explain the law of Laplace. How can you remember? Here is a L. L mean wall. Wall have two L. That's why it is called Laplace. LL Laplace. We have to. How can you remember the value? One is the Fick principle and the Frank Starling. Frank Starling mean F. F mean the flow. Okay, it's all about the flow. If inflow is more, the outflow is more. Okay, and the law of Laplace means if L. Now we will explain it. Okay, if wall tension or pressure, okay, how law of Laplace, for example, if balloon enter may pass in flow, for example, there is a balloon at the first time, for example, if it have no air, okay, if you want to inflate the balloon, first of all you need a so much force, okay, but if the balloon is become high and high, so after that, for increasing for increasing the balloon size, there are only less pressure is needed for you to inflate it, just like a baby. When the baby become born, okay, at the burning time, when the baby become born, okay, when the baby become born, what will happen? For example, this is the for example the baby born. So during the birth time, the alveoli are not inflamed. There are no air present. It okay, and their radius is so much less. Okay, but so first time baby need a deep breathing. Are sometime you have to breathe automatically. You have to breathe air inside. Okay, so at the crying time baby breathe deeply, so the volume the alveoli become inflated and their radius become high. So now, for example, first of all, if the radius is 2, okay, and law of Laplace wall tension is equal to 8, so there are only the radius is 4. Now only 4 amount of pressure is needed. First of all, you will explain wall stress. Wall stress is equal to wall tension divided by 2 wall of thickness, or you can say that pressure multiplied by radius. Okay, this is wall stress. So wall stress is equal to, if the radius is 2, you need a pressure of 4. but but after when the it burn and they start breathing, now their radius become 4, and at the 4 there changes. Okay, now you see that the pressure they needed is only 2, so the pressure is decreased. If the radius is increased, the pressure for the wall stress, the pressure is needed less. This is actually the law of Laplace. Okay, if wall stress is equal to wall tension PR, if the radius is become increased, so there will be less tension is present, and less pressure is important. Less pressure is needed. So in aortic stenosis, what will happen? More pressure is needed and hypertrophy is created. If more pressure is needed, so this wall become thickened. If this wall become thickened, so it become hypertrophy, and increase in the wall thickness become increase. If the wall thickness increases, the radius is actually less. So now you can see that if radius become decrease, what will happen? The wall stress become decreases. Okay, this is simple phenomenon. For example, this is the wall thickness. If the wall thickness become increase, the wall stress is actually to increase. But here also you can see that the radius is actually decreased. If the radius is decreased, the wall stress also decrease, just like wall stress is directly proportional to radius. If radius is decreased, wall stress is also decreased. This is all about the law of Laplace. Okay, law of Laplace, we have to understand about the law of Laplace. Now we will tell about the Fick principle. In Fick principle, for example, Fick principle is actually say volume ejected by left ventricle per unit time. It is actually cardiac volume. It find cardiac volume, but by different level, not by merging. It actually by oxygen. At rest, oxygen in and O2 out. For example, at rest, how many oxygen in and how many oxygen is out. So cardiac output is equal to oxygen consumption divided by arteriovenous or oxygen difference. So normal cardiac output is actually 5 liter per minute. Okay, 5 liter per minute. This is actually normal cardiac output. So stroke volume is actually end diastolic minus end systolic volume. 120 minus 50 is equal to 70. Cardiac output is equal to stroke volume multiplied by heartbeat. So 70 multiplied by 70. Stroke volume is 70. Heart rate is 70. So it give you 4,900. Okay. So it means 4.9 liter or 5 liter. Okay. So and Fick principle, how can one volume is like we identify volume like from the. Now in Fick principle, cardiac output is equal to oxygen consumption divided by air to oxygen difference. Air to venous oxygen difference, that in the atrial how many oxygen difference is present in the atrial, so it give you cardiac output. Okay, so you can identify. There are many questions coming on the basis of the Fick principle. You have to use the Fick principle on that area. Okay, so thanks for watching.